Hi everyone, welcome to Solar Integrations. This is the channel where I like to share my latest projects to do with Home Assistant and my solar inverter. In today's video, I'm going to be sharing with you how I connected to my BSL batteries. They're using a PACE BMS, so any battery which uses a PACE BMS will be able to use the same method. In South Africa, that's LBSA, Lithium Battery South Africa, SVolt, Revolve, Optimus Power, Jacopper, and a whole bunch of other manufacturers. Basically, any battery using the PBMS management software, this should work with. I think there may be some requirements from a firmware perspective on the BMS. If you have any questions about that, let me know and I'll do my best to help. This is a project that I've been trying to get done for a long time to try and get my data from the batteries, and I finally managed to get it right. There's a few things that you need to be aware of, and there's a lot of data that you'll be getting from your batteries. You don't want to get too bogged down in the data. So I'll be showing you what to look at, what to look out for, and what you don't really have to worry about that much. It's pulling a lot of individual power going into individual batteries. Some very interesting information about the design capacity and what the actual capacity of the batteries is. You can see that varies a bit, how many cycles the batteries have done. And then something else very interesting is the cell delta voltage, which is the difference between the highest and lowest voltage in your cells. Your batteries consist of usually 16 cells. So it'll give you that, and it'll also tell you if your pack has been balancing the cells or not, which is also pretty handy. Lots of information that you can pull, and I'll show you how to connect to it and what your options are and what you need to be aware of. So I hope you find the video interesting, and let me know in comments what you guys think. Okay, so the prerequisites for this project are going to be, you're going to need to have Home Assistant installed, obviously, and you're going to need to have ESPHome Builder installed, and you're going to need to have the file editor installed as well. ESPHome Builder and file editor can both be installed from the add-ons menu, so that's pretty easy to do. You just go to the add-on store, select ESPHome and file editor, and install them from there. You're going to need to have an ESP32 board, and it's going to need to have an RS485 port in it. For this project, I'm going to be using the LilyGo T-CAN485, which has got an RS485 and a CAN bus port built in. It's also got a power supply, which will allow me to power it with DC power, anything between 5 volts and 12 volts. So it's a very nice little board, and it's $11.86, so very reasonably priced. And I ordered directly from LilyGo. I'm not sure if it's available locally at all. I couldn't find any when I was looking, but very easy to set this up, and I'll show you how to do that shortly. You could also use a RS485 breakout board. Communica have had in the past, and Micro Robotics. Breakout boards can be more tricky though, with more soldering and that type of thing. So my suggestion, if you want an easy installation, is to go either for the T-CAN5 or the Electro Dragon RS485 shield. I have mentioned that in my video on connecting to your inverter before. Those are available locally as well. Okay, so the fourth thing you're going to need is you're going to need to have a battery with the PACE BMS installed in it. There's quite a list in the GitHub. I'll go through that quickly with you guys, but generally it's going to look like that over there. They don't always have the display, but this is a Revolve, which is available in South Africa. Sometimes they'll just have this panel on the front like that over there. There's a whole bunch of manufacturers who use them. They're very common. They're also used by BSL and a whole bunch of other people. So you will need, for this integration to work, you'll need to have a PACE BMS. There are other options available as well for other BMSs. So I wouldn't give up, but for this video, I'm going to be covering the PACE BMS. Okay, so the fifth thing that you might need is you might need a data link cable. Now, you're only going to need this if the RS485 communications is not working from your battery. So you would connect using this RJ12 connector using this RS232 port, and then you would use some software called PBMS tools, which I'll include the links for. You can download that, and then you need to go into the management software and enable comms over the RS485. This is a problem which I've found on the BSL batteries which I use. They've got the RS485 and the CAN bus connections disabled. I asked the guys from Get Off Grid to enable it for me, and they were very kind to do that. You may need to get into your some of the firmwares you can enable it without using the password. Some of them, some versions of this firmware, you will need the password to be able to do that. There is a default password, but I would be very hesitant to be going into the firmware and changing settings unless you know exactly what you're doing. So we will go through how to do that, but I would suggest you get your battery supplier or the support guys to do it for you if possible. Okay, sorry, I just wanted to say one thing. On the BSLs, it's not that these ports are disabled. These ports are usually used for communications with your inverter. On the SunSyncs and the DAIs, you're using the CAN bus port, and their default is for pylon emulation and on the RS485 port. So they're both set to pylon as standard, and you need to get that changed to the Modbus port so you can query it with the Modbus queries. That's just how these are set up, and that was one of the reasons why I could never get my connection to work, was because this is not set for Modbus connections as standard, and you need to change that using PBMS tools, or ask the really good guys at BSL at Get Off Grid if they can help you. They're very, very helpful with that, and once I figured out that was the problem, it was very easy to get sorted out. So the last thing we're going to need to do is to make a daisy chain cable between our batteries and our ESP32, the RS485. There are the right ways to do this and the wrong ways. This cable's very short, and RS485 is very forgiving. So the way I did it does work, and I'd like to, it's not strictly the right way. I did it in a star type topology. I'll show you guys how I did it. I'd appreciate your comments and whether you guys got it working. It's a very short distance, and it does work. So there is the option of getting these breakout connectors like this, where you would be able to daisy chain it very, very nicely. I think if I start having longer cables and start having issues, then I would be daisy chaining it using those devices. These aren't cheap though. They're like 150, 200 Rand each. So it would work out quite expensive to do it that way. I'm just using standard Ethernet cables. So I'll show you what I've done on that side. And that's everything we're going to need. We'll continue with setting everything up now. Okay, so these are the cables that I made up. You can see I'm only using pins 1, 2, and 3. Pin 1 goes to, which is normally orange and white. So normally orange and white, orange, green and white. So if you're going to use existing Ethernet cables, you're going to use the orange and white, orange twisted pair. Orange and white goes to pin B, orange goes to pin A, and green and white goes to ground. So it's 1, 2, and 3. And this one I made up my own cables. So there we can see we've got pin 1, 2, and 3, and they're all going into the same ports over there. So all of the pin 1s go to pin to RS485B, and all of the pin 2s go to pin A, and all the grounds go to the middle one. So I hope that makes sense. This is on the LilyGo TCAN485 board that I'm using, and that seems to work very nicely. So the first thing I'm going to do is I'm going to onboard my ESP32 into ESPHome. So I'm going to take my my LilyGo TCAN485 board, and I'm going to plug that into my computer. And I'm going to add a new device, and I'm going to use ESPHome Web to do that. I'll tell it to connect over here, and you should be able to see when I plug my board in, it'll add on over there. So I know it's on COM15, and I go connect and prepare for first use and install. And that will now connect and go through the installation process. I'll fast forward through the installation for you guys. Okay, so installation is complete. I'm just going to add the Wi-Fi now. I'm going to connect to my local Wi-Fi and put the Wi-Fi details in. It will connect to my Wi-Fi. So now it's getting my ESP32 to connect to my local Wi-Fi. Once that is in, I can now go to ESPHome. It's detected the device, and I can onboard that device. I can take control of that device. And I'm going to call this battery BMS, and I'm going to put my Wi-Fi details in there. And it's going to install a default Wi-Fi settings over here. I need to put in my Wi-Fi settings and install that as my default to the board. Okay, so I'm just going to update my Wi-Fi details over here. If you haven't used secrets before, the secret YAML file in Home Assistant, I suggest you do that. It's a great way of keeping your passwords out of your configuration files and that type of thing. And I'm not going to go over how to set it up over here. There's plenty of videos on how to do that. So this is going to pull my SSI, my Wi-Fi SSID and my password from that file. And I'm going to save that, and I'm going to update my ESP32 with that. Okay, so once you've successfully onboarded your your ESP32, you'll see, if you go to the logs, you'll be able to see that it's connecting to your Home Assistant and that everything's running properly. If you then go into this code over here, you'll want to go to SYSSI's ESPHome PACE BMS page, and you're going to go to the multiple battery examples. Now, the way this works is you can support multiple batteries. They all run on a daisy chain connection. So they're all on the same RS485 connection, and they have different addresses for each battery. Now, those addresses are set with the dip switches on your batteries. So battery number 1, number 2, number 3, and that is relevant to the Modbus address. So you've got your controller settings over here. You will set how many, this is the pack, sorry, let me just get back. So over here, you will set how many packs you have and what the Modbus address is for each pack. So there I've got 2 Modbus controllers, BMS 0 and BMS 1, and you give it the Modbus ID for each one of those and the friendly name. For this, I'm only going to use the 2. You can have as many of these as you want. The thing to be aware of is that this connection is quite a slow connection. It runs at 9600 baud rate, and each of these Modbus connections is querying in the YAML code. You can query, where is it? If you look back over here, in each battery, there are 114, it's about 120 entities that you can query, or addresses you can query on the Modbus register. So if you're querying each battery and you've got like 5 batteries, that's 600 queries on a 9600 baud rate connection. Your update time is going to start becoming, you're not going to have a live connection. It'll take 2 or 3 minutes to connect. I'm sure you can work it out exactly. And if someone in comments would like to tell me how to do that, I'd appreciate it. But you're going to have a slower update time. On a battery, I don't think it's really the end of the world. You don't really have to have a live feedback, but you need to be aware of that. So what's going to happen with this multiple battery, we're going to load both of these YAML files onto the ESP32. The first one will tell the ESP32 how many batteries you have, and then for each battery, it's going to update it with this pack info. The pack is each of the addresses on each battery that you're going to be connecting, so you don't have to redo this, 5 times in your ESP32 code, which makes life a whole load easier. I'll show you how we're going to install that now. Okay, so what we're going to do is we're going to download this this pack.yaml file to our computer. We just download the raw file, and that'll, on your one, it'll be called pack, just pack.yaml. I've downloaded this multiple times going over this demo. So if you just go to pack.yaml, and what we're going to do is go into ESPHome, go into File Editor, and we're going to go to our ESPHome directory. And in that directory, we're going to upload that pack.yaml file. So pack.yaml is over there, and I'm going to upload the pack.yaml file into my ESPHome directory. And I'm then going to go back to ESPHome. Now you'll see it appears in your directory. It doesn't have an ESP32 associated with it, but when I update this code's going to reference this pack.yaml file, and it's going to, when it compiles it to be loaded onto my LilyGo CAN485 board, it's going to be including this as well. So I'm now going to go over here. I'm going to go through to my multiple battery demo, and I'm going to copy this code over here. Now I've already got some of this stuff at the top over here, so I'm going to have to update this, the default code from the GitHub page. So there is the start of the code. I'm going to take out my this over here. I'm going to take out ESPHome. I'm going to leave all the substitutions in. Their ESP boards, so I can take that out. I can take the logger out. I can take the API out. I can take that stuff. The only thing I'm really going to need to put in here is the Wi-Fi details, which are already correct because they're also using secret. So that's all good to go. And I can save that. If you're using keys and that type of thing, you obviously need to include your keys in that. And then I'm going to go install, and I'm going to install that wirelessly onto my board. Okay, so that has successfully installed. And if you have a look here, it's not connected at the moment, so it's not going to be getting any data from the batteries, but that all looks good. One thing I just wanted to make sure you guys understand, if you want to have more than 2 batteries, then you will just uncomment out, unhashtag this over here, and this over here you can add for as many batteries as you want. I'm just going to install it for 2 so you guys can see the results from that. Okay, if you want to see all the stuff you can query with your with the Modbus addresses, there is the Modbus protocols on the GitHub page that I've included for SYSSI. On there, you'll be able to see all the addresses that you can use. And if you just scroll down over here, need to go to more pages. He's got a full list of all the Modbus addresses. There's quite a lot of stuff over there. Okay, so the first thing we want to do is just check that our dip switch settings, that our battery IDs are at the correct address for the querying of the Modbus controllers. We're going to be using address 1 and address 0. They need to be at those addresses. Those you set on the dip switches on your battery. Battery number 1 will have dip switch 1 on. Battery number 2 will have dip switch 2 on. So these cables need to be plugged into those 2 batteries for it to work. Okay, so if we're still not getting any data from our batteries, then what we need to do is connect to the battery BMS and check what protocols it is using on that RS485 port. We're going to do that using a USB to RJ12 cable. You can either buy from Solar Assist I've got for 500 Rand, or you can buy from this Electronics FG I've got. They're $400. Otherwise, I think Communico I've got. If you know anybody else that's got any at really good prices, let me know in the comments. Otherwise, I think you can probably get them off Temu as well. And that's going to plug into the RS232 port on the on your battery. So we're going to plug that into our laptop, And then the other thing we're going to do is we're going to download, you can get it from the lioch.com website, PBMS tools. I usually just use version 3, and you can download it from there. And that's what we're going to run on our laptop. So if you don't want to go through this, the best thing is probably just to speak to your battery supplier and ask them if they can remote in and change their setting for you. Otherwise, if you go to PACE BMS tools, this is version 3. The other versions look slightly different. What you're going to have to do is go, and it really depends on, I believe, the firmware that you've got. Some of them, this is password protected. Most of them it isn't. You're going to go to your inverter protocol settings. Down there, you're going to click on that, that arrow. Then you're going to click on read, and it will read what the current settings are. On the BSL batteries, it's usually set for Pylon Tech. We're not using the RS485 port for anything else, so it's not really a problem to change that. Your CAN bus port you use for your battery communications with your inverter, so you don't want to change that at all. And then what we're going to do is just switch that to PACE Modbus, because that's what this ESPHome integration uses. And so once that's set to PACE Modbus, write it, and then we should be good to go. Okay, so finally, just the dashboard. If you've got all your data coming in from your batteries, you've got a few options. You can either make a dashboard just using those sensors like you've got over there. Go to add dashboard and create a new dashboard from scratch. Let's just call it BMS2 and go create. And then if you go to your integrations, ESPHome, go to the BMS, and if you click at the bottom here, you can just add those to the dashboard. And we go like that, add that to the dashboard. And that's going to add all the entities that you've got to the dashboard. And if we have a look over there on the side there, we can see everything has been added. If you want to add something that's a little bit prettier, what we can do is we can go to edit the dashboard in raw configuration. Let's just take this out. If you go, I'll include a link to my GitHub page. It's just a fork of SYSSI's. I've put a submission in for him to add this in. I put some YAML code in there for a sample dashboard. If you just copy that and you paste that in, what you're going to need to check is that your entity names are correct. You may need to update this with your entity names if yours are different for some reason. Maybe you change the name of your ESP32, and then you should come up with a dashboard like that over there. I hope that all makes sense, and I hope you found the video useful. If you have, please remember to like and subscribe, and I look forward to hearing from you guys. Thanks for watching my video.